Good evening to everyone. We are going to discuss in application of carbon nanotubes in battery. Application of carbon nanotubes for lithium-ion battery. Introduction. Traditional energy resources are depleting day after day, and energy storage devices are reversing considerable attention. Lithium-ion batteries are representative energy storage device based on electrochemical energy storage and conversion. With the discovery of highly reversible, low voltage lithium intercalation carbonaceous materials, Sony realized that commercialization of LiX-C6 or Li1-XCO2 cells in 1991. Second, mechanism of lithium-ion intercalation and absorption in carbon nanotubes. As a promising candidate for lithium LiV anode materials, CNTs have been widely researched with regard to lithium-ion intercalation, absorption and diffusion, both theoretical and experimentally. It has been suggested that lithium ions are stored via two mechanisms, intercalation and alloying. Many studies have been performed in order to investigate the mechanism by which lithium ions are stored in carbon nanotubes, including theoretical works. Young et al. Proposed a surface mechanism by which the naked surface of carbon nanotubes and carbon nanoparticles are able to store lithium species through investigation of the electrochemical intercalation of lithium into raw-ended closed UNTs. Since the carbon nanotubes examined were end-capped and no extra treatment were employed, the lithium absorbed can only be localized at the surface of carbon nanotubes. CNTs, structural descriptions and their application of anode materials for LIBs. CNTs, carbon nanotubes have generated great interest among research as a unique materials since their first discovery by Eligimo in 1991 using an arc change method. They are considered as one-dimensional structure owing to their high aspect ratio, and SWCNTs and MW carbon nanotubes are two of the most important structures. CNCTS as anode for LIBS. SWCNTS can be envisioned as a rolled up graphene sheet with diameter ranging from 0.4 to 2 nanometer and length up to 1.5 centimeter. They can be described by a lattice vector m, n and a chiral angle which determines diameter and chiralities of SW carbon nanotubes. MW carbon nanotubes as anode for LIBs. MW carbon nanotubes with concentric graphene layers spaced 0.34 nanometer apart display diameters from 10 to 20 nanometer and length of hundreds of microns. SWCNTS can be described conventionally by chirality vectors. In contrast, the prediction of electronic properties of MW carbon nanotubes, which contains multiple layers of graphene sheet that may have different chiralities, is more complicated. Fourth, freestanding carbon nanotubes paper for LIBs anodes. The investigation and development of flexible power source has motivated the development of flexible, lightweight, wind-free and current collector-free electrodes for LIBs. In conventional method for fabricating LIB electrodes, binders are introduced to inhibit the collapse of the active materials from metal current collectors, while current collectors are used to maintain the electrode conductivity. Conclusion and future prospects. In recent years, many effort has been made to fabricate anode from raw CNTs in attempt to replace graphite-based anodes. Varying success has been achieved depending on the synthesis method and treatment methods applied. Thank you.